This lecture, we want to cover composite functions. Let's just take a quick minute and review functions and function notation so that when we cover composite functions, we'll make sure we're all on the same page. Function notation, when you first learned about equations with two variables, x and y, you learned about equations like this, y equals 2x plus 3. But then we learned function notation is basically where you replace the y with f of x. So this is like the function f, and f of x means, and this equation is going to have the variable x in it. So function notation is pretty handy to do things like this, where you want to set x equal to 2 and then find the value of the function. So f of 2, that means every place you have an x, you plug in a 2. If I wanted to determine f of -1, every place you have an x, you plug in -1. And then we even looked at, it doesn't even have to be numbers, it can be f of a. Every place you have an x, you plug in an a. As a matter of fact, you could do something like this, f of x plus h. It's the same principle over and over again. Whatever's inside here is what you substitute in for x. So this one would be 2 times x plus h plus 3. Well, what if I did something different and I went over here and defined a second function? Say I said, here's another function, g of x equals 2x. And then I said, how about finding f of g of x? Okay, what would this mean? Well, this means you take your f function, and every place you have an x, you replace it with the whole g function. So 2 times x, instead of x, you replace it with the g function, which is 2x. So f of g of x would be 4x plus 3. Well, what's interesting is what we've done here, this f of g of x, they like to give this a special notation. So they put f and then this empty circle g. And what they call that is the composite function. Now here's how I always do composite function problems. Normally, for instance, here's an example problem. F of x is 2x squared minus 3. G of x is 4x. And then they ask you, what is f composite g of x? What I always do whenever I have a composite function, I always go back and rewrite it like this, because this to me is very clear, obvious, and easy to understand what to do. This notation is just a little funky. So whenever I have a composite problem, I always, first thing, rewrite it like this. Because this I understand. This says you go get the f function. Every place you have an x, you replace it with the g function. Alright, so the f function is 2x squared minus 3. So I'm going to rewrite the f function 2. But I'm not going to put x squared. I'm going to replace the x with my g of x, which is 4x. Now since it's x squared, this thing gets squared, and then minus 3. Now if I were to simplify this, it would be 16. F composite g of x is 32x squared minus 3. All right, not very difficult. And you know what I could have done? They could have said, what is g composite f of x? Once again, first thing I'm going to do is I'm going to rewrite this. In this case, it's g of f of x. Now let me take a minute to define something that we're going to have to talk about in a few minutes. When you have a composite, the second function listed, which ends up being what we call inside of the other function, we end up just calling this the inside function. So for f composite g of x is what we will call the inside function. For g composite f of x, turns out f of x would be what we call the inside function. Now in a minute, you're going to see why it's important and why I call those inside functions. Let's go and finish this problem. So g of f of x, I go to the g function, 4 times x, but in place of the x, I'm going to replace it with the whole f function. So 4 times x, but instead of x, I put in the whole g function. Now if I distribute the 4, 8x squared minus 12. Now someone could, or sometimes you'll see problems like this just to be sort of fun or a little goofy. So here are my two functions. And sometimes I give you a problem like this. F composite f of x. Well, all I do is I always rewrite my composite functions. F of x. So it says I go to my f function, 2x squared minus 3. Now, x squared, I replace x with my f function. And of course, you square it, 2x squared, then minus 3. I'm not going to take the time to simplify this because the whole key was just to show you this right here. Now what they'll do sometimes is, sometimes they'll give you a problem where they just want to have the new function in terms of x, but sometimes, let me rewrite my two functions here. So we said f of x equals 2x squared minus 3. G of x equals 4x. Sometimes they'll have a composite like this. F composite G. Now instead of x, they go ahead and stick a number in there. So it's really F composite G of 3. Now once again, first step is always to rewrite this composite. So in this case, it would be F of G of 3. Now this ends up being easier to solve than what I have been doing, because I can immediately I can go ahead and plug in the 3 into my G function, and I can plug that number in here. So it's G of 3 is 4 times 3, which is 12. So this really becomes F of 12, and now I get my F function, and I plug in 12 for x. I made this up. This is like, I think this is like 288 minus, if I did the math correct, something like that. But you see the idea. Or if they said G composite F of 2, what does that equal? When you go ahead and right away you can figure out F of 2. 2x squared, 2 times 2 squared minus 3. This is 8 minus 3, 5. So it's really, okay, I didn't do what I said to always do. Rewrite the composite as this. And now F of 2 is 5, so really the problem becomes G of 5. G of x is 4x, plug in 5 for x. There you go. All right, composite functions. Hopefully you realize they're not that bad. Now, let's talk about one feature, one kind of problem they're going to ask you. Oftentimes, I'll ask you for a composite, and then they will then ask you also for the domain. Remember, the domain is all possible values of x. And really, hopefully you remember our previous talks about domain. Really, the domain, the thing we're having to look for is if you have any equation or expression with any x's in the denominator or any x's under the square root, right? But there's a little twist here. So to find let me just write it out. It's only 2 steps. What you do is of course, F composite G of x is F of G of x. Remember a few minutes ago I said, in this case, G of x is called the inside function. If you're asked to find the domain, you first go look at the inside function just by itself and determine that domain. So once again, what you're looking for, you'll look at the inside function and you'll look to see if there are any variables in the denominator or any variables under the square root. If not, the domain is all real numbers. But if you have either of those two things, then of course that changes the domain, and that's something we've talked about before. So you may have to go back and review how to find the domain if you've already started to forget some of the principles there. So the first thing is you look at the domain of inside function. Actually, I'll make this 3 steps. Then you go ahead and you do the math to find the composite function. In this case, f composite g of x, f of g of x, you get some equation or expression. And then you look at the domain of the composite function, and you do the same thing. You're looking for variables in the denominator, variables under the square root. And then at the end, I'll just write here combined domains, because we've looked up 2 different domains. You looked up the domain of the inside function and the domain of the composite function. You have to sort of combine these domains. Whatever is not allowed in either of these functions, that is not part of the domain. All right, let me do a couple of examples, and then hopefully you'll see how the domains isn't really that hard. How about f of x is 2x plus 5. G of x is 1 over x minus 1. So they want us to go ahead they ask for the composite. What is f composite g of x? And then when we're done, they also want the domain of the composite. So let's go ahead and figure out the composite first, and then we'll look at the domain. So once again, f of g of x. So here's my f function. I'm going to plug in my g function in for x. And actually, I want to go ahead, in order to make it easier to find the domain, let me combine these into one fraction. So my denominator is going to be x minus 1. So I can take this second, get the common denominator. I have 2 plus this, if I multiply it out, 5x minus 5. So there's the composite function. Now, what's the domain of the composite function? Well, the domain, once again, is 2 parts. First, you look at the domain of the inside function. The inside function is this g of x. G of x is 1 over x minus 1. Now if you recall, when we're looking at domains, we assume the domain is all real numbers unless we have a variable in the denominator or a variable in the square root. We have a variable in the denominator. What do I know that x cannot be equal to? X cannot be equal to 1 because we can never have a 0 in the denominator. So the domain for this all real except x cannot be equal to 1. So that's the inside function. Now, if I look at the composite function, it's right here, and ask myself, what's the domain of the composite function? Well, once again, my main concern is I have a variable in the denominator, and once again, x cannot equal 1. Turns out it looks like the domain of the composite is going to be the same as the domain of the inside function. Since these are the same, the overall domain are real except, I probably should write it, all real except x equals 1. Or I'm not sure what the correct math way to do it. I sort of like it like this because it emphasizes x cannot be 1. Anyway, that's how you do that. Let me do another example. Here's a problem. F of x is 1 over x plus 2. G of x is 4 over x minus 1. And they want to know what's the domain when you take the composite function f composite g of x. So it looks like g of x is going to be the inside function. So the domain of g of x are real except x cannot be equal to -1. Oops. Positive 1, sorry. Right, positive 1 will cause the denominator to be 0. Now I have to also go find the domain of the actual composite. So we have to figure out this composite function. So composite, in this case, would be f of g of x. So I take my f function, 1 over x plus 2. In every place I have an x, I plug in the g function. So 1 over x, instead of x, I put a 4 over x minus 1. Wow, looks pretty messy. What I need to do is go off to the side and once again combine these into one term or one fraction. So I need to get a common denominator of x minus 1. So now I can combine them. 4 plus 2x minus 2 so this is this now. So it's still going to be pretty messy. This is now a complex fraction. And when we simplify this, it turns out this ends up being so this is actually the composite function. So now my concern is, what's the domain of this? Here I have a variable in the denominator. So what? I have to be very careful that the denominator never equals 0. What value of x would cause that denominator to be 0? X cannot be negative 1. So the domain R real and x cannot be negative 1. So now you combine the fact from the inside function, we determine that x cannot equal 1, and from the composite function, we determine that x cannot be negative 1, so we just combine it. And you see the overall domain, R real, except x cannot be equal to 1 or negative 1. All right. So that really covers sort of the principle and the idea of composite functions. And these are some standard problems. Now let me go ahead. There are a couple of problems in the online homework that I need to explain. So actually I brought the textbook in. And I'm going to go and work one of each of these kinds of problems in the textbook that might be a little confusing at first, but once you see what they're getting at, I think you'll find it not very difficult. So let me pull this textbook over here and hopefully I can make it so you can see it. I want to look at number 9. Let me try and zoom in. I'll try and focus. So number 9, it looks like a table. You notice the first row says x, so these are values of x, minus 3, minus 2, minus 1, 0. Then the next row says f of x. So in other words, f of x is a function where if x is minus 3, f of x is negative 7. It's almost just like f of negative 3 is negative 7. F of negative 2 is negative 5. F of 0 is negative 1, right? But then they've got another row of g of x. So this is for the function g. So across the top are the values of x. So if I want to know g of 1, here's x equal to 1. G of 1 would be 0. G of 2, I go to the x equals 2 column. G of 2 would be 3. G of 3 would be 8. So that's how this table works. Now off to the side here are the questions. And I tried to cover them up because this book has the answers. I don't want us to see the answer right away. So they're saying based upon this table, look at this table and determine f composite g of 1. Well, what you really want to do here is rewrite the composite function. In this case, it just makes it so much easier. F composite g of 1 becomes f of g of 1. So now we say, what is g of 1? Well, we go to our table. I go to the x equals 1 column, which is right here. So g of 1, I go to the g row, it's 0. So this really becomes f of 0. And now f of 0, that's saying what is the f function when x is 0. I go to the column where x is 0 and the f function is minus 1. And in a minute, we'll look and hopefully that's a correct answer. How about this next one? G composite f of negative 1. All right, these problems become a lot easier if you rewrite it. So this becomes g of f of negative 1. So you always work like from the inside out. F of negative 1. So what's the function f when x is negative 1? Here's the negative 1 column. F of negative 1 is negative 3. So this problem becomes g of negative 3. So now, this is saying what's the function g when x is negative 3? X is negative 3 here, and the function g is 8. Then we'll do this one here. It's interesting. G composite g of negative 2. G composite g of negative 2. If I rewrite that, g of 2. So I say, oops, negative 2. So I say, what is g of negative 2? So I go where x is negative 2 and the g function is 3. So now, g of 3, when x is 3, what's the g function? Looks like 8. So, those are the kinds, you'll have some of these problems on your homework. And I think once you see it done, you realize, wow, not too difficult. But at first glance, it might be confusing. Matter of fact, let's see if our answers are correct. Hope I didn't mess up. So it looks like negative 1, 8, and 8. And that's what we got. So they even have more problems, but it's the same kind of thing. Not very difficult. Now here's a second kind of problem. Instead of giving you a table, that will give you two graphs. And you notice, if you look at this graph, the lower one, that's the graph of f of x. So this is like the f of x function. The graph with the arcs and the higher graph is g of x. And you notice, here's your x-axis. So it's almost like the typical, you have your x-axis, and then the up and down is the value of your function. So based upon that, I tried to cover up the answers. Here are some questions. Based upon this graph, what would g of f of negative 1 be? Matter of fact, let me just write it here. Not g of f, g composite f. So first thing I would do, always rewrite this composite as g of f of negative 1. So now you start from the inside out. F of negative 1. I want to know what does that equal. That means go on my graph, go on the x-axis where x is negative 1, and then go to the graph of the f function, and find the value of the function. This is basically saying, what's the value of the f function when x is negative 1? Well, x is negative 1 is right here. The f function is this one here. What's the value of the function? It's 1. So this now becomes g of 1. Now you're going to go to the graph and say, okay, let's go my graph, and wherever x equals 1, find the value of the g function. Well, x equals 1 is right here. The g function's up here. What's the value of the g function when x is 1? 4. Let's do a few more. This one says f composite g of -1. So here they switch the order. So f composite g of -1, this is why you always rewrite the composite function, f of g of -1. So we go find out what does g of -1 equal. So x is -1. I'm looking at my g function, which is up here. Looks like the g function is 3. So now this becomes f of 3. So I go to my graph, I go to x equals 3 and find the value of the f function. So x equals 3 is right here. The f function is this one down below. Now, I wonder if I made a mistake, because normally they would give me the point here. Oh, let's make sure I didn't make a mistake. Here's the problem, f of g of -1. G of -1 is 3. So f of 3 looks to me, it's not marked. Let's see, we look at the answers. Looks to me it's like around -1. I thought they would have put one of their dots there with the point, but I guess maybe not. Let's do this one. Whoops, you can't see my finger. About the one labeled B, G composite f of 0. Which is g of f of 0. What's f of 0? Well, here's x equals 0, and the f is this one right here, looks like it's 0. So this really becomes g of 0. Once again, they don't really label it, but it looks to me like, my guess is it's 5. I might check to make sure I'm not messing something up. Let's go back and check this first one. I said was 4. That's correct. Next one I said was -1. That looks correct. This one I said is 5. Oh, you can't see. So this is the first one I did, 4. That's what we got, 4. Then I did this one, f composite g of -1, and we got -1. And then we did this one. They got 5. We got 5. Let's do this last one, f composite g of 4. Once again, first thing you always do is to rewrite it, f of g of 4. So go to my graph, g of 4, here's x equals 4. Here's the g graph. Let's go up there, and the function is 2. So this row becomes f of 2. So now I go to x equals 2, and I look at my f function. Looks like it's down here at -2. If I look at the answer, Yep, it's -2. All right. So these are two kinds of problems you have in the homework. So once you see how they're done, I hope you realize they're not very difficult. All right, so I think that's the main stuff for composite functions. You should have everything you need for the homework. If there's something I didn't cover, you can always look in the section of the book.